We are discussing wave on a string. Okay, velocity of wave on a string is this one, and where mu is linear mass density. And when a standing wave is produced on a string, fixed end it must be node, free end it is antinode. That's the rule. Okay. But of course, if you think about sonometer experiment, it is fixed at both ends. It is fixed at both ends. That's the rule. Okay. So we start with first one. First one is that a string which is fixed at both ends. String fixed at both ends. Anyone is there who knows the formula or derivation of it? Anyone can give the answer for this situation? What is the final answer? Now, let us consider a string which is fixed at both ends. You can take example guitar string, sonometer string, anything you can take, no problem. Okay, string fixed at both ends you can take. How it can vibrate? Remember this. The rule is that fixed end must be a node, so it can vibrate like this. It can vibrate in multiple ways, but let us take the first possibility is vibrating like this. It is vibrating in a single loop. Let us take length of the loop is L. L is equal to lambda by 2. Yes or no? Because distance between two nodes is lambda by 2. That implies lambda is equal to what? Tell me? 2L. And observe V is equal to nu lambda. So I don't write this step here. I'll I write the step directly. Nu is equal to V by lambda. Okay. And I will write the direct step. V is equal to root T by mu and 1 by lambda. 1 by lambda is 1 by 2L. Understood? I wrote the direct step over there. That implies nu. This is one. You need to know some statements. Statements, I'll give it to you. Just observe, this is the thing. Whatever possible, the minimum possible frequency is called as fundamental note. Fundamental note. See, note, the word is very frequently used in music. Film industries, in music they use a lot. Note is nothing but a frequency. In physics term, I can say it's frequency. Okay, fundamental note. Now, that's the only possibility. No, we have multiple possibilities. One among them, just a minute, one among them will be vibrating in two loops. That is like this, check it. We have a loop here, one more loop here. But the condition is satisfied, check it. Fixed end node, and one more node is in between. Next possibility. In that case, L is equal to 2 lambda by 2. So 2 gets cancelled. Don't cancel it. Uniformity will be there. Distance between these two is lambda by 2 and lambda by 2. 2 lambda by 2 is equal to what? L. That implies lambda is equal to 2L by L. That implies frequency is equal to root T by mu. This is velocity into 2L by L. In denominator, sorry. So this is fine. Why we call it as nu2. No problem. That's the end. That's only two possibilities. Anyone is that got the point, sir? There are three possibilities or infinite number of possibilities. I think you got it right. It has infinite number of possibilities. The third one is like this. Okay. Now in this case, L is equal to 3 lambda by 2. That implies lambda is equal to 2L by 3. That implies nu3 is equal to not L, 1. 1 minute. Sorry, I did a mistake.
No, it is
By mistake, I
2L
wrote
by L.
2L by L. Yeah. This is 2L, right? Okay. Here 3L will come. Check it. 3 by 2L, not 3L. Root T by mu. If I start making it, I can make up to infinity. It doesn't ends there. Okay. It doesn't ends here. It keeps on moving. So on. Sir, can we develop a generalized equation? Definitely yes. Okay. Right. So I can say so on up to infinity. So a shortcut formula has to be developed. Okay. A shortcut formula. So on, let us take it. Nu n is equal to n by 2L into root T by mu. Got the point? Okay. Now, a small point to be noted. Let us take this fundamental and all these three. Some statements I'll give. Don't ask me why. You need to understand those statements and deal with it. Okay. These kind of questions are there in mains. Advanced Kunjigami, but mains it is there. That is the first statement I'm giving it to you. That is minimum possible minimum possible frequency is called as fundamental frequency. So it is obvious in all these things is fundamental. Okay. Second one, natural number multiples are harmonics. Sir, what is this? Actually, many textbook will give integral multiples. Sorry, I think you can't see what I'm writing there, right? Now you can see that, right? Clearly?
Yes, sir.
Yeah.
Yes, sir.
So minimum possible frequency is equal to fundamental frequency or is called as fundamental frequency. And natural number multiples are harmonics. Natural number multiples, that means you take the multiples of fundamental frequency. Just a minute. Let us write only fundamental. Good. Now it's correct. Natural number multiples of fundamental are harmonics. Minimum possible is fundamental. Now what to do? You take the first one, multiply with 1. It is first harmonic. This is first harmonic. Multiply with 2, second harmonic. Multiply with 3, third harmonic. And so on it goes, right or wrong? It doesn't end. So these are harmonics. 1, 2, 3 are harmonics. Clear? Then all possible, all frequencies above fundamental are overtones. When I give these three statements, generally you feel, okay, sir, what's there in it? Right? Okay. Above fundamental or overtones means what? You leave the fundamental, There's first harmonic overtone, second overtone, third overtone, like that. And you feel that why they did this nonsense, I don't understand. Why they are saying like this? This is first harmonic, second harmonic, third harmonic. First overtone, second overtone, third overtone. Why two different numbers? One thing is that why two different numbers, even I don't know. Okay. I don't seriously find any good reason there, but it is given. And so take this one. Nu n is equal to n by 2l root t by mu is the thing. N is equal to 1, 2, 3, or so on. N will give you harmonic, n minus 1 overtone. Sir, understood? Very simple logic. So you can remember this, why we need these statements. You will understand these statements in the next segment. So you have to mug it up. You have to deal with this one most of the times, because whenever sonometer experiment questions are being given, you will use this one only. So this is the thing you need to remember. Okay, right. Any doubts anyone has? If you write these two formulas side by side, then you will understand. Observe that, sir, harmonic formula, something here, overtone is okay, and little complex it is. First thing, what I'll tell you is that, remember this formula, and 2n minus 1 also, you remember the formula, first point. These two you try to remember. Okay, just remember those two. Now, what is harmonic? Don't try to remember harmonic. Whatever is here, this is harmonic. Whatever number comes there, that's harmonic. Don't worry about it. Okay. Overtone is n minus 1. That's it. So one small statement I'll give. I observed that it will help some students that in entire my set of formulas, plus never comes. Some textbooks will give plus here. In my set of formulas, plus will never come. Clear? So we need to learn a little bit about sonometer. See, once you understand wave on a string, you need to understand sonometer also. Sonometer is a device, is a wooden dabba, actually speaking. It's a wooden dabba. And there will be two knife edges or bridges also, we say. You can adjust the length of you can adjust the length by moving it to and fro. Both you can move, actually speaking. You can move both. And we will add some weights. This weight will give you downward mg. Okay. And tension will be T. So we can calculate tension of the string by using mg logic over there. Nothing else apart from that. You can start working on it. The rule is these two ends must be node. Okay. And what we do is that, observe this one carefully. First of all, we keep the bridges very, very close. And then we take a tuning fork. Assume this is the tuning fork, okay? And we'll strike it, keep it there. If the frequency of this, remember, frequency of that dip will be like this, right? This one. So I'll do one thing, I'll copy. Whatever we got by this formula, the length is this one. Substitute here for frequency. The frequency that we got it here and the frequency of tuning fork is same, then that phenomenon is called as resonance. Not yet completed, but that's called as resonance. At the time, we keep a small paper rider on it because we can't see the vibrations. With the little bit of vibration, the paper rider will fall off. Okay. Like that will happen. So, sir, if paper rider doesn't fall off, my question is, why it won't fall? Sir, that the tuning fork frequency may not be equal to what? Tell me. The natural frequency. Then what we do is that we adjust it, we'll move it little towards right. So in a trial and error method, we keep on increasing. Like that. Okay. Once you start keep on increasing, just a minute. I'm not able to pick up. keep on increasing like that, there will be one length where you get what? The rider will fall off exactly. That's the resonance frequency. Clear? So that's what you need to understand. Let us start with the sonometer. Okay. So first question. Easy to deal with. Make it fast. Quick. Now, first question, sir, I understand everything, but I don't understand the meaning of what? Polarization. Take it as polarized, that's it. Okay. Wave on a string will be definitely transverse standing wave. And it is polarized. Answer is Charlie C. First one, Charlie. You'll understand only after what? Completing entire optics, wave optics, right? There we discuss about all the properties of wave. That is diffraction, polarization, reflection, refraction, everything. So fine. 32, go ahead with it. Next question. In this, simply they're asking speed, no need to worry about it. V is equal to square root of T by mu, formula substitution.
One ten, sir.
Perfect, 110. Simple formula substitution, check it. 110 meter per second. Okay, 33, don't solve. Don't solve 33, go for 34.
Sir.
Okay, one small thing I'll tell you. Okay, small thing I'll tell you that in 33, only problem is that 33 question, small point is there, mu is not given. They gave density. Density is equal to mass by volume, but mu is equal to mass by length. How do you get it? That is equal to mass by length into area. Length into area, right? Now, length is, this can be taken as what? This one. So, density is equal to mu by A. How do you get area? Generally, wires are taken as cylindrical by r square. Check it, radius is given, radius or diameter is given there. Yeah. Oh, directly they gave area, no problem. They gave direct area. Simply substitute A. Mu by A is rho. So, mu is equal to rho A. That's it. That's the only small thing you need to remember. Nothing else. Of course, most of you already know. But I need to teach. 34.
20, sir.
Yeah, 20. Perfect. 34, 20. Easy one, right? Yeah, make it fast. Next one. Anyone want me to explain 34?
No, 10, 33.
34 you want?
Can you come 34 too?
31st one you want me to explain, right?
Yes, sir.
Okay, so observe 34. Just read slowly. If you think, you will definitely get that. 34. The velocity of wave on a fixed string is 2. V is given. What's the meaning of it? You don't need to calculate root t by mu in the formula. It's already given by default. So V is equal to meter per second. A string forms standing waves 5.0 centimeter apart with nodes. So node to node, what is the distance? Lambda by 2 is equal to 0.5, right? Meter. Node to node is lambda by 2. Node to antinode is lambda by 4. That implies lambda is equal to 1 meter. What do you want? Frequency. Frequency is equal to velocity by wavelength, mu by lambda. What is velocity? 2. What is wavelength? 1, right? 1 minute. 2 meter per second, 5 centimeters. See? Meter I took. Gone. So 5 centimeter. 0.5 centimeter, 5 centimeter. See? I don't know why I took 0.5. 5 centimeter. 5. What is the meaning of 5 centimeter? 5 to 10 centimeter, right? 10 centimeter is what? Tell me 0.1 meter. 0.1 meter. Right. So 0.1 here, 0.1. That is 20 hertz. Okay. Observe 35. A stretch string of length L fixed at both ends can sustain stationary waves of wavelength lambda given by. Okay, N is the number of loops. Remember this. We have a fixed end. The fixed loop thing is there, right? Length is L. Length is what? Tell me. L. Oh, wait a minute. Capital L they used. Capital L. I don't know how many loops are there. N loops are there, assume in that. Each loop gives you lambda by 4. N into lambda by 4 or 2 because one loop means lambda by 2. N lambda by 2 is equal to L. Yes or no? That implies lambda is equal to 2L by N. 2L by N. Answer C. Go for 36. This can be solved in 2 different ways. You can use the formula. Nu n is equal to n by 2L into root t by mu. This is the formula, na? Okay. So question number 36. Standing wave 10 centimeter long stretch string and 5 segments. So 5 segments means that implies what? Fifth harmonic. Nu 5 is equal to 5 by what is length? 10 centimeter. That is 20 centimeter, right? No, meter only. Thank God. 10 meter long. So no issues. Into root t by mu. You don't need to worry about t and mu because they gave directly root t by mu 20. So what happens? 20 gets cancelled. It will be what? 5 hertz. One way, or else other way is also there. Observe a string is there. A string is there. Totally 1, 2, 3, 4, 5. 5 segments are there, right? Totally 5 segments are there. Isn't it? So 5 into lambda by 2 is equal to how much? 10 meter. That implies lambda is equal to 4, isn't it? Because 2 here, 20. 5 will come to denominator. 20 by 5 is 4. 4 meter is the lambda. Isn't it? I got lambda. So frequency nu is equal to V by lambda. That is equal to, what is the velocity? 20 meter per second. By lambda is 4. 5 hertz, you can take it like that. Okay. So 37. Make it fast. Anyway, you can do. Question number 37. Original frequency of note produced by sonometer is N. What is original? Frankly speaking, there is no such thing called as original. But we understand the what? Kavi Hrudayam. Kavi means the poet. So the examiner will take it as a poet and he write poetry. and he expect us to understand exact poetry. It happens sometimes, no? Leave it. Let us continue. So in that, the original frequency or the fundamental frequency is N. Okay. Sonometer. Sonometer means fixed at both ends. Okay. Reduced in length. Okay, fine. Frequency is N. Let us take nu n formula. Nu n formula is equal to N by 2L. N by 2L into what? Tell me. Root T by mu. Good. What is that? What is it? The sonometer wire reduced length half to original value and tension increases 4 times, right? So what to do? You know very well. What we need to do is we have to make a circle around the constant. That's what the practice I'm doing. And whatever variables are there will be left without circle. Then simply we write nu1 by nu2 is equal to L2 by L1. Why? Because it is in denominator. That's why L2 by L1. Then T1 by T2 because it's a numerator, but square root because root T na it is. This is a thing most of you already know maybe, but just I explain. So length is reduced to half. Initial length is L, final length is L by 2, and tension became 4 times. Initial tension is L T, final tension is 4T. Now you can cancel T, L also gets cancelled. 1 by root 4 is 1 by 2. So your answer will be 1 by 2 into 1 by 2. That implies initially we got what? Frequency N. Yeah, nu1 is equal to 1. Nu2 is equal to 1 by 4. If you solve it, nu2 is equal to 4n. Answer is Bravo B. Answer is Bravo B. If any place, if you feel that you're not able to, please ask me. 38. Right. Double the frequency. How do you produce double the frequency?
40 Newton, sir.
Yeah, 40 Newton. Yeah. Simple 40. This is also identical one and relatively easy one. The tension of the wire is 10. What should be the tension of the wire produced? Note double the frequency. Very simple. Nu n is equal to n by 2L root T by mu. So n is constant. This is also constant. L is constant. Mu is constant. Only tension T, right? That implies nu1 by nu2 is equal to T1 by T2 under root. Under root is because T is under root. T1 by T2 rather than T2 by T1 because T is in what? Numerator. That's it. Nothing else. So what they want? Frequency double. Right? Initially 1. Okay. Initial frequency is nu. Final frequency is 2 nu. Double the frequency they're asking. Is equal to square root of initial tension is T. Of course, T value is given. So substitute the value there. 10 Newton. Final T2 that we don't know. So first of all, nu gets cancelled. Squaring on both sides will give you what? 1 by 4 is equal to 10 by T2. That implies T2 is equal to 40 Newton over 39.
B, sir.
What? How to go about 39? Okay, I'll explain. Tension of a stretched string is increased by 69%. Okay. Stretched string is increased by or increased to. Both are different. Increased to means what? Initially 100. It is increased to 120 means final is 120. But same thing. Initially 100. Of course, percentage means we take it for 100. Okay. Increased by 120 means finally 220. Do you understand? That's okay. So the tension string is increased by 69%. So initial tension T1, if you take it as 100, final tension T2 is but 169. There's a rule you need to understand. Right. In order to keep the frequency of vibration constant, length must be increased by. Good. Now observe, we have to take the formula. Nu is equal to N by 2L root T by mu. Nu is equal to N by 2L root T by mu, right? Now concentrate, they want to maintain the frequency constant, right? N constant, everything. Mu also constant. Now what to do? That can be written as L can be taken here. So L is directly proportional to root T. If you want, you can write, or else you can write direct step. What does that tell me? L1 by L2. Sir, L is the denominator. No. Once it comes here, it becomes numerator. L1 by L2 is equal to T1 by T2 under root. Because they give percentages, initial must be taken as what? 100. So L1 by L2 is equal to 100 by 169 under root. So what is the value? 10 by 13. So that's fine. But try to understand this one. L1 by L2 is equal to 10 by 13. What is my point is that, see, they gave in percentage, they're asking in percentage. So to understand the change in percentage, always keep initial as 100. If I multiply with 10, you will get 100, right or wrong? So if initially is 100, finally is how much? 130. How much increased? 30% increment. Increased by 30, increased to 130. Clear?
Sir, I equated both and so, sir.
The fundamental frequency of a string stretched with a weight of 4 kg is 256 hertz. The weight required to produce the octave. Octave. Octave means double, right? So nu is equal to n by 2l root t by mu. Where is weight here in this formula? Where is weight? Weight liye, isn't it? Weight. Where is the, is very simple. Tension, right or wrong?
Sir,
It
yes,
is
sir.
inside the tension. That implies what? Nu is equal to n by 2l root mg by mu. So 2 same, n same, l same, mu same, everything is same. Wait, let us do one thing. Mg itself is kg weight. Let us not calculate m and then do all the, anyway same. That implies what? Nu1 by nu2. Sir, why you are taking nu2 as 2 nu? Octave means double. Octave means double. Sir, how it is double? It's double, that's it. Don't ask me. M1 by M2. G you can cancel. Let us oh wait, M1 is also given. Let us cancel these two. And squaring on both sides, 1 by 4 is equal to, what is M1? What is M1?
4 kg, sir.
4 kg. M2 is, that's what we need to calculate. That implies M2 is equal to what, tell me? 16. Mass is 16. Weight is 16 kg weight, or 16 into 9.8 or 10, whatever you want. What is meaning of kg weight? See, kg weight is a unit of force. That means maybe 10 kg weight. What is the meaning of 10 kg weight? The force applied is equal to the gravitational pull on 10 kg mass. What is gravitational pull? 10 into 9.8. So 98 Newton is called as 10 kg weight. Or if you take G is equal to 10, it is 100 Newton. Okay. So just leave it. This is the thing. Answer is 16. Okay. Yeah, go ahead with 41. Make it fast. Anyway, 41. Two strings AB of lengths LA and LB. Okay. Let us go for that. LA is equal to 80 centimeters. And LB is equal to X centimeters. What's the meaning of it? Why they give unit for variable? They say that you have to give the answer in terms of what? Centimeters only. That's the reason. Unless it's not, if it is not mentioned, which units we have to give? By default, we take SI. Right? Okay. SI units. Respectively are used separately in a sonometer. Good. The ratio of the densities dA by dB is 0.81. Oh, dA by dB is equal to 0.81. Fine. The diameter of B is 1/2 of A. Oh, diameter. What symbol we use? Wait. If diameter is half, if diameter is half, Radius also have, na? Radius of B is equal to half of radius of A. Yeah. If the string is having same tension and fundamental frequency value, and for, okay, fine. So nu n, or let us take fundamental frequency. So nu, simply take nu, no need to worry about that. Nu is equal to 1 by 2L root T by mu. Wait. Length is different. They give density. They haven't given linear mass density. Linear mass density is equal to mass by length. I gave, right? Density is equal to mass by volume, we know. That is equal to mass by length into area. That is equal to, what is mass by length? Tell me. Mu. Mu by area. That implies, wait, mu by area. Everything is fine. That implies mu is equal to density into area. Area is pi r square, right? Substitute this value here. So by doing it, this is and density is equal to, good. So that is equal to 1 by 2L root T by density into pi r square. Now pi, same tension. This is also same. Wait, frequency also same. So what I'll do is that I'll write in the next step. Nu is equal to, nu is also same. What are variables L and R? Isn't it? Oh wait, rho is also there. So what I'll do is that I'll bring L onto this side. L will become numerator. That implies L will come to numerator. L1 by L2 is equal to rho 2 by rho 1 under root. Observe, R square under root gets cancelled. It will be R2 by R1. Wait, sir, they gave A and B. Yeah, generally if it is given, what we do? What we do, tell me? 1 will be taken as A, 2 will be taken as B, no problem. That's it. That is equal to, observe, L1 by L2, 80 by X is equal to rho 2 by rho 1, 1 by 0.81 under root. Sir, why? 1 is A, 2 is B, over into R2 by R1. What is R2 by R1? 1 by 2. Right? So 1 by 81. 100 by 81 I can write. 100 by 81 means 10 by 9, right? Observe. 1 by 0.81 can be written as 100 by 81, right? Under root, 10 by 9. Clear? So if it is 10 by 9, I can do one thing. This can be written as 10 by 18, right? This entire value is 10 by 9. This is 1 by 2, 10 by 18. That implies cross multiplication. X is equal to 18 into 80 by 10. Right. What is the answer? 18 into 8.
240.
Yeah. Answer is there, right? C. Two uniform strings AB made up of steel are made to vibrate under same tension if the first overtone of A is equal to second overtone of B. Wait, how can we say the string is fixed at both ends? If they use the word sonometer, then yeah, good. We can take fixed at both ends only. But steel wires, they said, first overtone is equal to second overtone. Okay, but if they use the word harmonic, second harmonic, remember second harmonic is possible only in case of fixed at both ends. Sir, ambiguity, yeah, there is an ambiguity. What to do? By default, if not, you can take it as what? Tell me, fixed at both ends only. Fixed at both ends only. How to? Okay. So assume it is fixed at both ends. Same tension. If the first overtone of A equal to second overtone of B, so nu A is first overtone, right? So what is the first overtone? 2 by 2L root T by mu. Right or wrong? First overtone. Sir, I don't understand. Do you remember fixed at both ends law? N minus 1 is the overtone number. Not only that, anywhere n minus 1 is the overtone number. So overtone number is what? Tell me, first overtone. That implies n is equal to 2, right or wrong? Whatever we got here, that we have to substitute in this script, right? Good. And frequency of B is equal to, what is the value? B. Second overtone of B. Second overtone of B means what? N minus 1 is equal to 2. This is for A, this is for B. Don't get confused. That implies N is equal to what? Tell me, 3. 3 by 2L root T by mu. 1 minute. I got the confirmation that T is same. I can use same T for both. But mu is not same. So what I do is that LA, mu A, LB, mu B I have to use. Wait, it is not ideal to use B here, mu formula here, because density and radius is given, right? Radius is twice that of B, right? So the density into pi RB, sorry, RA square. Now you replace this with what? Tell me. Density into pi RB square. Second overtone of B, if the first overtone of A is equal to second overtone of B, oh, both are equal, right? We'll equate them. This, they're equal. Length of the string, good. I think tension is same, cancel. 2 gets cancelled, obviously. Pi also gets cancelled. And density is same. Made by, okay, made of steel. Both are steel, so density is also same. It is a little bit irritating for me, so I will rearrange it. 2 by LA is equal to, sorry, 2 by LA into 1 by RA is equal to 3 by LB into 1 by RB. Sir, what happened? Square root. Square is there, square root is there, gets cancelled. Good. Now what to do? That implies what? Question number 43. The radius of A is twice that of B. The radius of A is equal to twice that of B. Be careful. Sometimes you may go in the other direction. So I can replace this one here. And I'll take LA on this side. And I'll bring 3 on this side. I'll do all these things and then I'll get it like this. It will be 2 by 3. I brought 3 there. I'll take LA on the other side. 1 by, what is RA? 2RB is equal to LA by LB. I haven't done anything with RB. I'll keep RB there. Don't worry, RB gets cancelled. Right? 1:3 answer. Clear? Remaining 2 homework you have to solve. Okay. That's all for today. Thank you.